What's up, everybody? We're going to talk about areas between curves again today. This is what I'm calling 7.2 day 2. In day 1, everything fit perfectly into our definition, and we always had one function larger than the other the entire time, and we were only talking about two functions. Today, the complication we're going to add is it's not always going to fit this description, so we might need to break it up into two or even more individual problems in order to apply our formula or definition to it. We're just going to learn this through one single example today, and this is from number 36 in your textbook. What it says is to find the area of the region in the first quadrant bounded on the left by the y-axis. I think as we're going I'm going to start coming up with a sketch of this to see if we can model it. Well, I saw the word first quadrant, so I'm only going to build the first quadrant here. Let's see, bounded on the left by the y-axis, so it looks like we're going to be dealing with this right here. Below by the line y equals x over 4. That's just a line with a slope of 1/4. That's this. And I'm thinking it's starting to get complicated enough that maybe to get a good sense we'll graph this in our calculator to see where we're at. So let's move this down a bit. We had the line y equals x over 4. So let's see, let's just put x over 4 right here. If we keep reading, it says above by the curve 1 plus root x. And then above right by the curve 2 over root x. Let me change my window. I only care about the first quadrant, so I'm going to go from 0 to 10. That still might be too much. Same thing for the y, 0 to 10. Take a look at our graph. There's the y equals x over 4 that I've drawn. Here's 1 plus root x. And there's 2 over root x. So if I get back, I'm going to put this right next to the paper to try to... I don't care about most of this graph, but what I do care about is kind of in here. So let's try to recreate that again. The 1 plus root x looked like this. The 2 root x started, or 2 over root x started up here and kind of crossed here and continued out like this. The most difficult part of this problem is going to be deciding which region we're really talking about here. So I'm going to read through one more time to try to figure that out. Again, it said we're bounded on the left by the y-axis. So that tells me it's either going to be this region or this region, because here's the y-axis. Below by the line y equals x over 4. I'm starting to think it's this one, because this was our y equals x over 4. This was our y equals 1 plus root x. And then this one up here was y equals 2 over root x. So below by x over 4 looks like that's this. Let's continue reading and make sure it really is this part here. Above by the curve y equals 1 plus root x. And I think in the book I might have left it out here. It says above left by the curve 1 plus root x. That's this. And then above right by 2 over root x. So if this were our region that I'm going to call R, here would be above right. So it looks like I'm only going to very lightly shade it in. It looks like we're talking about that region right there. Well, there's a further complication here, because everything we did in 7.1, when we looked at our region, there was one function that was the larger function the whole time and one that was down below. And when we look at this, it looks like for part of the time this function is the larger one, and then the other part it's this other one here. So what makes this a day 2 is we're going to need to split this right here. And by splitting that right there, now we have two different distinct regions where this one, for the first half, this function is larger than this one the entire time. And then for the second part that I've shaded in, this other one is larger than this one here for the entire time. So by breaking it into two, we can just apply our definition or formula 2 different times. The key to this is it looks like up front I know that this part's 0. So when I go to write my area, the very first one is going to have a lower limit of 0. It needs to end wherever this was. and that's where 1 plus root x is intersecting with 2 over root x. So let's bring the calculator in again for a moment. I have all the curves here. Second calc, intersect. For the first time, this upper left matters to us. We need to pick the right curves. That's a wrong one, because to find this point right here, I don't care about x over 4. I care about 2 over root x and 1 plus root x. I'm going to hit the down arrow until I see one that I want. Okay, 1 plus root x, that is one of them that I want. That's good. I'm going to hit enter. The other one I want is 2 over root x. Pick that for me, so I'm going to hit enter. I'm going to ask the guess. I'm going to move the cursor over here. Hit enter. It intersects at x equals 1. So in terms of on paper, what we needed to show is I need to show that I'm setting 2 over root x equal to 1 plus root x. And then since I did the work on the calculator, I can then skip to an answer of x equals 1. So I know that this part right here is 1, which means I know that this part right here is a 1. And then at least for the first region, the upper function was 1 plus root x. Subtract out the lower one, which was x over 4. Keep our notation straight. That's going to give me this part. I'm going to want to do another definite integral, which starts at 1. Where should this one stop? Well, that's where this intersect point is. So this time, this point is where x over 4 and 2 over root x intersect. So again, in terms of work, I want to show that I'm setting 2 over root x equal to x over 4. Use our calculator if we want. Hit second calc, intersect. X over 4 is one of the ones that I want. I'm going to hit enter. Now I don't want 1 plus root x. I want 2 over root x. There it is. Hit enter. It asked me to guess, so I want to slide my cursor way out here to where it looked like that other point was. Guess. It found an intersect of x equals 4. So I can say that right here. That means this other one needed to go from 1 to 4. So for this region, the upper function is 2 over root x. So that's what I'm going to put here, 2 over root x. I want to subtract the lower function, which is x over 4. Get our notation right. So that's a dx there. Most important part here is the setup with the calculator ready step. You're going to have the most difficult part figuring out the region. So I would read through once, twice, even 3 times in order to try to find your region. So we have these 2 different regions here we were really looking for. Once again, we can use our calculators today. So I'm just going to leave, I'm going to go to my y equals just to see what I had done, and maybe I'll leave myself a note on the paper. So this first one, 1 plus root x, is what I stored in y2. X over 4 is what I put in y1. So this first one I'm going to do y2 minus y1. The second one, 2 over root x, is what I put in y3. X over 4 is what I put in y1. Okay, so back to the home screen, second enter for copy paste. I need to do y2 minus y1. That first one's from 0 to 1. And it looks like we get approximately 1.5416666877. I want to see if that's a nice fraction or not, so I'm going to hit math fract. Doesn't look like it is, so I'll be okay anytime that happens that we just write to 3 decimals. So on paper I'm going to write a is approximately 1.54. I'm going to write it on paper to 2 decimals, but I think what I should do is store that value in alpha A. I still need to do this other one over here, so I'm going to hit second enter a few times, fn int. This time I need to do y3 minus y1. Let's see, y3 minus y1, and this one's going from 1 to 4. 2.125. That one's going to be a nice fraction. Probably doesn't matter since we have this other decimal. We're going to end up with a decimal here. So I want to take and add that to what I stored in alpha A. Looks like we get an answer of 3.667. Try one more time. It didn't know the fraction. .667. Alright, so be creative today. Come up with a nice graph of it. Use your calculator if you need to. Try to break it into regions if you have to in order to make it one function above the other one the whole time. All the problems you do today, you should be able to break it up so that it does eventually meet our definition. Alright, good luck on this one. We'll do one more day of areas that we'll practice in the coming days. Won't be too bad though. Alright, take care. I'm out of here. See you soon.